Hello, welcome back. Today we want to talk about working with measurements, or more precisely, probably we should say, using numbers from our measurements in calculations. So to begin, let's just remember that when we had a measurement, the first digits are the ones that we know for sure, and then the last digit is the estimated digit. So for example, if we had taken a measurement 23.7 degrees Celsius, the last digit was the estimated digit. So this digit's estimated. The next digit over here we know absolutely nothing about. We have no idea. We had an idea that we knew it would definitely pass the 23 tick mark and that it was probably about 0.7 between those, but we definitely don't know anything about the next digit. So let's propose a thought example for this. So in this example, let's imagine that I, and this will be me, every morning wake up and I weigh myself. And when I weigh myself every morning, I'm wearing a pair of shorts. So me and my shorts, this is me, these are my shorts that I'm wearing. Hop on a scale. My bathroom scale at home, let's say, reads 182 pounds. So when I say I weigh 182 pounds, that's me and my shorts. Now imagine I want to know about just what the weight of my shorts are. How much do my shorts weigh? I'm sorry. That is not what I'm looking for. I want to know about just what I weigh without my shorts. So to do this, I first find out the weight of just my shorts. So I take my shorts off, get dressed, come into work, and I put my shorts on a more precise balance here in the lab, and it tells me that my shorts weigh 0.25 pounds. So I weighed 182 pounds with my shorts on. Then I brought the shorts into the lab and I weighed them on a more precise balance, and it told me that they weighed 0.25 pounds. Remember that my balance at home told me I weighed 182 pounds. This last digit here is the estimated digit, and we don't know anything else about the digits beyond that. So it might have been 182.4, might have been 182.1, it might have been 182.0. We just really don't know. In this case, the balance told us 0.25 pounds. This is the estimated digit, and we don't know anything beyond that. But we do know that it was 0.25 pounds of shorts. So the question for you, or that we're posing here in this thought example, is how much do I weigh without my shorts? So most people would just subtract this. You would say, and we can do this, you'd say 182 minus 0.25 is 181.75 pounds. But if you're thinking this through, you might be able to see ahead here that I didn't actually know for a fact what any of these digits out here were. What if it was 182.4? Then that would be an entirely different number. What if it was 182.3 or 182.1? Then that would be an entirely different number. So I really can't tell you with any certainty what these numbers are now because I didn't know them to begin with. So the best thing to do, the only way to handle this, is to just sort of draw a line here. And whatever number this one, the least one, stopped at, that's where I have to stop as well in my final answer. So this one stopped in the ones place, this one stopped in the hundredths place, but my final answer needs to be the least precise, the one that went to the least digits. So I need to round my final answer to here, and I need to say I weigh without my shorts 182 pounds. And I need to accept that this still is the estimated digit, that there still might be some variability depending on what exactly that one was to begin with. I wasn't 100% sure of that digit then, so I'm still not 100% sure of it. It wouldn't surprise me if without my shorts I really was 181 pounds and that was just measurement device error, because that's my measuring device. My scale at home was estimating that digit, and it wasn't 100% perfect. It wouldn't have been shocking to find out that my balance was a little bit off and it really should have been 181. And if I went to the doctor's office, I'd find that out. So that's how we deal with precision in addition and subtraction problems. because we have a set size of the measurement, so when we're adding or subtracting, we can just round off to whatever number was least precise to begin with. So the precision of this number stopped in the ones place, so whatever my answer was, I had to round it to the ones place. In multiplication and division, we have to handle this a little different way, because the numbers can get much larger or much smaller when we're multiplying numbers. We have to count what's called significant digits. And the basic way to do that is pretty simple. We'll get into the nitty-gritty of how to deal with zeros in class, but here I just want to show you the simplest way. Let's say we are multiplying two numbers. Say we're going to take 2.1 centimeters and multiply that by 3.0 centimeters. And for good measure, let's actually, make this 2.10 centimeters and 3.0 centimeters. So when we're counting significant digits, you literally just count the digits. Now zeros in some cases cannot count, and that's what we'll talk about when they don't count. For now, let's just assume they all count. So here we have 1, 2, 3 digits in this number, and here we have 1, 2 digits in that number. So when we do multiplication and division, we just round our answer to the least number of significant digits. So since this one had 2 and that one had 3, then 2 is the least number of digits. We'll round our answer to 2 digits. Whatever it turns out to be, we'll round it to 2 digits. And that'll be it. So we'll go ahead and multiply these. 2.10 times 3.30 is 6.30 centimeters. And because this one had 2 digits, I need to count off 1, 2 digits and round the number here. So that number will go away. I will report this as just 6.3 centimeters squared. The unit is centimeter squared because it's a centimeter times a centimeter. So that gives me a centimeter squared as my final answer. So again, for addition and subtraction, you just count to the last digit. So this one stopped in the 1, 2, or the ones place. So the final answer needs to also stop in the ones place. This one, you count the number of digits. This one had 3 digits, 1, 2, 3. This one had 2 digits, and you just round your answer to have that number of digits. That's it. Thanks for coming along with me.